In this lesson, we are going to learn about combining half cells of redox reaction and balance the redox reaction. Here are the general steps. In most cases, the half cell will be given in terms of oxidation and reduction, but sometimes they will give you some other kind of data that allow you to determine which one undergo oxidation. Let's look at the example. In this case, we are not given in terms of oxidation and reduction, but we have the reduction potentials. Now if we go back, the one with the lower reduction potential undergo oxidation. So if we have negative 1.66 and negative 0.44, this will undergo oxidation, which will be the opposite of reduction. So we have to rewrite this. So again, it's the opposite of reduction. So once we have our given oxidation and reduction half cells, we can now combine them together. Before we combine, we have to balance the electron. Notice how this process of oxidation gives off 3 electrons, where this reduction process gains 2 electrons. 3 and 2 are not even, so they don't cancel out. So we have to find the common multiple. So for the oxidation, we have 3, and for the reduction, we have 2. What do they have in common? We look at the common multiple. So 3 times 1 is 3, 3 times 2 gives you 6. Where 2 times 1 is 2, 2 times 2 gives you 4, but 2 times 3 gives you 6. So they have a common multiple of 6. In this case, 2 times 3, and in this case, 3 times 2. So what we need to do is that we go back and we look at, hey, 3 times 2 gives you 6, so I'm going to multiply everything by 2 to give me 6. So in this case, I have 2 times 1, that gives us 2. 2 times 1 again, that gives us 2. And then 2 times 3 gives us 6. For the reduction, we have 2 electrons, but 2 times 3 gives us 6, so we multiply everything by that. So in this case, it's going to change all the coefficient in the reaction, just like we just did to the oxidation part. So we have this multiplied by 3. So now 3 times 1 gives us 3, of course. 3 times 2 gives us 6. 3 times 1 gives us 3. So notice how the electrons are both 6. When you combine the two half cells, we just combine the reactant together and then we combine the product together. Just be careful when you look at the oxidation. Just make sure you're using the one for oxidation, not the reduction that's given to us. So in this case, we have 2Al plus, oh, there's nothing left. And then we go down to the other half cell plus 3Fe 2 plus 6 electrons. And that's all we have for the reaction. Now we're going to combine the product together. So going back to the product, we have 2Al 3 plus 6 electrons. And then we are done with that half cells. We go down here, we look at the other half cells, which is only 3Fe plus 3Fe. So this is your reactant, and this is your product. That would be step 1 and step 2. Now, step 3 is a cancel light reactants and product. What does that mean? Notice how the reactant has 6 electrons that cancel out the 6 electrons with the product. So after we cancel out the 6 electrons, we couldn't find anything in common. We have aluminum, but that is aluminum solid versus the ion. We have Fe2+, that's the ion where this one is solid. So we just have our final reaction equal to 2Al, and this is our balanced redox reaction, taking account of canceling the electron together. Let's try a more challenging problem. In this case, we have the two half cells give us in terms of oxidation and reduction. So all we have to do is follow the step. First, balance the electron. Notice how we have 2 electrons are being given off, where 1 electron is taken in through the reduction process, so we have to multiply this all by 2. So we multiply everything by 2, this can now have 2, 4, 2, 2, and 2, and we can remove that 2. So now we have 2 electrons being added in and 2 electrons being produced. The next step is combine the half cells, basically taking all the reactant, add together, and take all the product added together. So what we have here is your reactant. So we have 2Cl minus. And what we have next is the product. In this case, the product is Cl2 plus 2 electron. So that's step 2. For step 3, we just cancel out the like reactant and product. For instance, electron, we have electron on the reactant, we have electron on the product. So they are alike, which they are the same, so we can cancel out 2 and 2 electron. Do we have anything else that are alike on both reactant and the product side? In this case, Cl minus, nope. H plus, nope. Cl3 minus, nope. So our answer will be this, except for without the electron part. And this would be our answer. Let's try another problem. In this case, our half cells are given in terms of oxidation and reduction, so that makes it a lot easier. Let's balance the electron. We have 2 electrons in the oxidation and we have 2 electrons in the reduction. Hey, look, it cancels out. Then we combine the half cells. Basically, you take all the reactant and you add them together, and you take all the product and you add them together. So the rest is just rewrite them in a complete reaction. So again, this is coming from that part right there. And this is coming from this part right there. So I combine the reactant together. Now I do the same thing to the product. So again, this is right here. And this part is right there. The next step is cancel like reactant and product. For instance, the easiest one is electron. We have 2 electrons, cancel out with the other 2 electrons in the product. Then we look at water. We have 2 water molecules here, and we have 1 water. So one of the 2 water molecules will be canceled out with that one. So we have nothing over there, then we have 1 left over here. Then we look at the NO2. We have 2 NO2 here, then we have another NO2 there on the reactant side. Guess what we're going to do? We are going to combine them together by simply just adding them together. So 2 plus 1 give us 3. So we have 3 NO2. Then we have H plus. We have 2 H plus here, but we have 4 H plus here. So that 2 gonna cancel out, and 2 of those gonna use to cancel that 2. So we have 2 left. So 2 H plus left. So there's nothing left on the reactant. We combine this together already. The next thing is we look at the product. That one is still left, as well as this one. So what we have to do is rewrite all this mess into a prettier one. So what we have left is 1 H2O, 3 NO2, and producing 2 NO3 minus, plus 2 H plus, and plus NO. So what we have here. So this is what we have left. Water molecules, 3 NO2, and on the product side we have 2 NO3 minus, 2 H plus, and 1 NO.